So on problem 4 on the practice exam 1, we need to find the compositions of these functions. The first one being f composed with g. And then we also need to find the domains. So remember that this is the same as f of g of x. To find that, we want to take the g function, plug it into the f function. 2 over x minus 4 under the radical. This can be written, if you want to, as the square root of 2 over the square root of x minus 4. Doesn't really matter though. To find the domain, the thing in the denominator, it can't be 0, and this quantity that's under the radical can't be negative. So put those two things together, you get that the quantity under the radical has got to be greater than 0. It's got to be greater than 0 because of the radical, can't have any negative numbers, and it can't be equal to 0 because of the fact that it's in the denominator. So solving that gives x must be greater than 4. So the domain is 4 to infinity, not including 4. Okay, then we want to do next g composed with f. Okay, so composing g with f is just the reverse. Now we're going to take the f function and plug it in to the g function. So take that, plug it in there. 2 over the square root of x minus 4. And then for the denominator here, what has to be true? Well, it can't be equal to 0. So let's set it equal to 0 and what makes it, and then solve it, and that'll tell us what makes it 0. So that gives root x must be, or root x is equal to 4. Square both sides of this, we get x is equal to 16. So that's telling us that x cannot be 16, and then also since the x itself is under a radical, it has to be greater than or equal to 0. Putting those two things together, that tells us the domain of this part of this particular composition is 0 to 16. Skip over 16 and then go 16 to infinity. Okay, then the next one is the f composed with f. And that means to take the f function and plug it into itself. F of x. If we do that, we get the square root of the square root of x. And for the domain on this one, it's pretty straightforward. The x is the only thing that's under the radical there, so that's got to be greater than or equal to 0. And in interval notation, you can put it as 0 to infinity. Finally, g composed with g. Take the g function, plug it into itself. G of x. And that will give us a complicated looking fraction, 2 over x minus 4 minus 4. Okay, now for this one, we're going to want to simplify it, but before we do, just realize that since this x minus 4 is in the denominator, that's telling us something about the domain. We'll just make a quick note of it. It's telling us that x cannot be equal to the number 4. After we simplify it, that might not show up, but let's go ahead and simplify this. Easiest way to simplify it is to multiply the top and the bottom by the thing that's in the denominator here, x minus 4. So we have to do that in both the numerator and the denominator so we don't change the fraction. So that's going to give us 2 x minus 4 up there in the numerator. Distributing this to this, the x minus 4 terms cancel. We just get 2 minus 4, and then that gets distributed there as well. So we have this. Simplifying this by distributing, we get 2x minus 8 over. Now if you distribute here, you get a minus 4x, and then you also get a plus 16. So you get actually 16 plus 2, that's 18. So 18 minus 4x. Okay, now we've got another term here that's in a denominator after we simplified. That also can't be 0, so let's set it equal to 0 and figure out what the domain is for this part of it. So for our 18 minus 4x, that gives us, let's see, we want to say 18 minus 4x is equal to 0. Figure out what makes it 0. If you saw this, you get 4x is equal to 18, so x equals 18 over 4. That's the same as 9 over 2. So that tells us x cannot be 9 over 2 either. And so if you put this together in interval notation, the domain of this last piece must be minus infinity up to 4. 4 is less than 9 halves. We go from 4 up to 9 over 2. And then from 9 over 2, 9 halves up to infinity. It's okay on the test to also just say x can't be these two numbers. That's good enough.